Good afternoon, dear students. Today we are going to see about the gaseous state for 11th standard. Gaseous state. First of all, we can survive without food for a week. We can survive without water for a days. But we cannot survive without air for minutes also. So air is that much important in our day-to-day life. Air consists of many particles in it. Okay, we need to inhale the air, which are the molecules are taken by our body. After that, there are unwanted particles are there inside our body. The lungs will exhale that. We need to give out. This is a long process. Day-to-day life. This is a everyday process. It should go like this. So there are many states of matter. Among them, today we are going to discuss about the gaseous state. Okay. Before entering into that, we should know the difference between the gas and the vapor. Gas and vapor. Normally, the gas is a substance normally exists in a gaseous state at 1 atmosphere pressure and room temperature. Room temperature is around 25 degrees Celsius. Okay. Vapor is a substance. Vapor is the gaseous form of any substance. Gaseous form of any substance. For example, a liquid or a solid. See, gas is a normally exists as a gas, but vapor is not so. It may be a liquid or it may be a solid at a room temperature and 1 atmospheric pressure. It exists as a gaseous form, that is called vapor. There is a major difference between the gas and vapor. For example, if hydrogen is a gas, always it's a gas at room temperature and 1 atmospheric pressure. Whereas a water, it is liquid. It can be made to a gaseous state. Water, vapor. This is called a vapor. But a gas is normally exists as in the gaseous form. So it's a gas, it's vapor. Vapor, it may be any substance in the form of gaseous state. Vapor is the any substance, either any substance means liquid or solid, in the form of gaseous state. That is called a vapor. Okay. As you know very well, in lower standards we have studied in the total air atmosphere 78% nitrogen, 21% oxygen, remaining 1% other gases. Okay. Then in the totally existing element, only 11 elements are naturally occurring as a gaseous. Only 11 elements. What are the 11 elements? Hydrogen, nitrogen, oxygen, fluorine, chlorine. These are the diatomic gases, totally 5. Then helium, neon, argon, krypton, xenon, radon. These inert gases, 6. So totally 5 plus 6, 11 elements. Total existing elements 11 only in the gaseous form. Even then here we have diatomic gases. Diatomic gases. What is called diatomic gases? The atomicity is 2. Then what is the atomicity? Number of atoms in a molecule is called the atomicity. Here if you take hydrogen, hydrogen molecule consists of 2 hydrogen atoms. 2 hydrogen atoms combined together hydrogen molecule. So always it cannot exist as a hydrogen. So it is always exists as a dihydrogen, that is called a hydrogen molecule. In the molecule, how many hydrogen atoms are there? 2 hydrogen atoms are there. So it is called diatomic. All those hydrogen, nitrogen, oxygen, fluorine, chlorine, all those are diatomic molecules, diatomic gaseous. Even especially oxygen can also exist as a gaseous form in the triatomic species. Triatomic species. Triatomic species. This is ozone. This is also gas. Then these are the monoatomic gases. Monoatomic gases. Helium, it can exist single. Helium, neon, argon, krypton, xenon, radon. 18th group or inert gases are monoatomic gases. Totally 11 natural occurring gases are available. This is in the elementary state, natural elements. In the form of compound, we have some gases are there. Carbon monoxide, gases, natural occurring gases in the form of a compound. Carbon dioxide, nitrogen dioxide, nitric oxide. These are the naturally occurring gases in the form, compound form. So totally 78% of nitrogen, 21% of oxygen, remaining 1% other gases, dust particle, inert gases like so on. Out of the existing element, we have 11 elements are in the gaseous form naturally. Among them, diatomic species are 5, H2, N2, O2, F2, Cl2. They are gases, diatomic gases, and then we have inert gases, all those 6 inert gases in the form of monatomic gases. So totally 5 plus 6, 11 naturally existing element as a gaseous form. Out of this, oxygen will have a triatomic gases also, triatomic part also. Since ozone contains 3 atoms of oxygen, so triatomic also is available here. Other than this element, there are natural occurring compound form of the gases also is there. They are carbon monoxide, carbon dioxide, nitrogen dioxide, nitric oxide. Okay. So these are the just introduction about the gaseous form we have. Now our lesson is not that we need to study detail about all those gases, physical and chemical behaviors. In order to govern the physical properties of all those gases, we have laws. Okay, they are called gas laws. All those gas laws we are going to discuss in this week one by one. Today we are going to take the Boyle's law. Before we are entering into the gas laws, we need to some terms and technologies we need to know. What are the terms involved in that? Then only let us move on to the laws of the gases. So before we entering into the gaseous law, the gaseous physical properties are governed by these factors: pressure, volume, temperature, number of moles. We should know that terminology before entering into the gaseous law. P is called pressure. What is called pressure? The force acting per unit area. Force acting per unit area. This is called pressure. It can be said this is a container, closed vessel is a container. If we take, there are gaseous particles there, lot of number of particles there. These particles are hitting towards the walls. This exerts the pressure. Force, this is hitting of the particle into the walls per unit area. That is force per unit area. So we know that force can be given by Newton. The area is meter squared. Further, Newton can be elaborated by kilogram meter per second squared divided by meter squared. Then the formula will be kilogram per meter per second squared. This is called a 1 Pascal. This is SI unit of pressure. This is SI unit of pressure. Okay. There are lot of other units are nowadays in use. SI unit of pressure is Pascal. Pascal the unit kilogram per meter square per second. Okay. Then what are the other units to measure the pressure? Atmosphere, ATM, atmosphere, bar, Torricelli, tor, then mercury, millimeter in mercury, and pound per square inch, pound per square inch. These are the other units to measure the pressure. The SI unit of pressure is Pascal. Once again I am explaining what is the pressure. Pressure is nothing but a force per area. Force per unit area. The force acting per unit area is called a pressure. In order to explain that what is the force is, this is a closed container. The gaseous particle, all particle is colliding into the walls of the container. The area, the force is given by to the area, that is called a pressure. Okay. Then volume. Volume you know very well. What is called volume? Volume is the space occupied by the body. That is called a volume. Space occupied by the substance or matter is called a volume. Temperature. What is called temperature? Temperature is a degree of hotness. There you should know the heat is different from the temperature. Heat is quantity of heat. The quantity of heat is separate, that is called a Q. That is represented as a Q. Don't have confusion. Temperature is different from Q. Q is a quantity of heat. But it's a degree of hotness. How much hot is there? That is called a temperature. That is T. Then it can be measured in the Kelvin. SI unit of temperature is Kelvin. You have other units, Celsius, Fahrenheit and so on. But always we are using the Kelvin. N equal to number of moles. Number of moles can be derived. N is a number of moles. Number of moles can be derived by the mass by molar mass, molecular mass. That is called number of moles. So N for a mole. Mole can be expressed in the term mass by molar mass. Okay. So these are the terms before we are entering into the gaseous law. Then let us move on to the first law, Boyle's law. Then gaseous state. One is Boyle's law, Charles law, and Avogadro law, Gay-Lussac law. Today in this class we are going to discuss about the Boyle's law. Boyle's law. So at a constant temperature is constant. Boyle's law simply we can see PV relation, pressure volume relation at a constant temperature. Pressure volume relation at constant temperature with a fixed mass is called Boyle's law. If they ask two more questions, define Boyle's law. At a constant temperature with a fixed mass, the pressure is inversely proportional to that volume of the gas. Pressure is inversely proportional to the volume of the gas at a constant temperature, fixed mass. Mass should be fixed. This is a Boyle's law. Pressure inversely proportional to that volume. He done a lot of experiment. Okay, after that only he is giving a derivation like this. Pressure inversely proportional to the volume. What is the experiment he has done? If we take a special apparatus, Boyle's apparatus, it's like a J tube. Take this. So the mercury, you fill with mercury, it is initial, figure 1, it's filled with the mercury. Okay, both are equal. The pressure will be exerted. It's an empty space. This is the space occupied by the gas that we can call as a volume B. Okay, this is full of mercury. Here also pressure. This is open side. This is closed side. Okay, difference is there. This is closed. This is open yet. Okay, now open end mean the here also pressure will be there. Here also will be pressure. This is called a pressure of gas inside. Okay. Here also gas, but we cannot say this because this open end. No, there is a pressure of atmosphere. Pressure of atmosphere. Okay, clear with this. This is if you clear with the first diagram only, we can move on to next diagram. This is a continuation. Okay, this experiment no. Mercury level are equal. This is empty, the space occupied by the gas. So I am calling it a V. There is a pressure exerted by the gas. That pressure is called the pressure of the gas. Here also, sir, why sir, this is pressure of the gas, this is the pressure of atmosphere you are saying. This is open. Okay, this atmosphere here, there is no closed. But here this is closed circumstance. So this is a pressure of atmosphere. Okay. What Boyle is doing this, Boyle want to do the experiment. He filling with the mercury, excess of mercury to that. He is pouring mercury like this. When he pours, after some times it reaches, this is normal level here, mercury. After some times, the volume of the gas is reduced to the half. So volume of the gas is reduced to the half. When it is happened, when 760 mm of mercury is added, after this the total volume is reduced to the half, V by 2. I am calling this V by 2. Again, this is again pouring some more mercury. This total volume is reduced to half. So I am calling this V by 3, this one, volume. So volume, half of the volume, here half of the volume, up to there. So here, this value, we consider this 1520 mm. So simply, again I am explaining this experiment. See, this is a apparatus used by the Boyle. He taking this like a apparatus. He is examining that, pouring mercury level, increasing mercury levels, pouring. After 760 mm mercury is added, he watched that the volume of the gas is there. No, this is reduced to half. At particularly 760 mm is added, it is the volume is reduced to the half. Again, he is pouring more mercury. After some time, there is a 1520. One more 760 is added. This that second volume is reduced to that half. So finally, he has come to the conclusion that when a volume is reduced to half, the pressure is doubled. The pressure is doubled. When a volume is reduced to the half, the pressure is doubled. So what is the relation between this? When a volume is reduced to half, pressure is double, mean that is inversely proportional. That's why he is giving relation this. Pressure is inversely proportional to volume. That much, when volume is reduced to half, the pressure is doubled. So he is giving this relation. Pressure is inversely proportional to volume. Pressure is inversely proportional to its volume. Okay. Further, developing this relation, pressure inversely proportional to the volume, there is a proportionality constant. To remove the proportionality constant, we can put a K by V. Then PV equal to K. It's a constant. This is mathematical expression for the Boyle's law. PV equal to K. There is where one gas and one volume. If you take many gases, then the relation may convert to P1 into V1 equal to P2 into V2, that is equal to P3 into V3, that is equal to constant. This is further expansion of this law. Further expansion of this law. P1 V1 equal to P2 V2, so on. It goes like this. Okay. Then graphical representation of the Boyle's law. The graph plotted between the pressure and volume. The graph plotted between the pressure and volume. What we are saying is there is a curve like this. Pressure, the curve will be like this. Whereas pressure against 1 by V, you will get a straight line. The slope will be going like this. A positive slope you can get. These two are given in the book here. For various temperature, you can calculate it. If a P1, P2 like this, it goes no. at a different temperature, pressure versus volume. This is for different temperature. For example, it is temperature at T3, T2, T1. Always T3 is greater than T2, T2 is greater than T1. This is a curve, graphical representation. Then, one more graph is there. The product of pressure and volume versus pressure. The product of pressure and volume versus pressure, you are getting the constant value because PV equal to constant. You are giving PV equal constant. This graph will be like this. The same, different temperature. If you draw this graph, 1, 2, 3, the constant value T3, T2, T1. The product of PV, pressure and volume versus pressure. Sir, what is the implies that, sir? What is we are going to say this from? Whatever this, the product of pressure and volume always constant. That is meaning for this graph. Never change. Pressure, the product of pressure and volume always constant. That's why PV equal to K or P1 V1 equal to P2 V2. That is equal to P3 V3. That is equal to K. We are saying that. This graph, it is inversely proportional. That means you are getting a straight line. The pressure increases, 1 by V also increases. That is a positive slope increases. What will this graph tells you? No? When the pressure decreases, volume will be increasing. Or otherwise, oppositely, if you draw like the same, volume, pressure increases, volume, pressure will be increasing, volume will be decreasing. This is one more graph you can draw by using log. That for neat purpose you should know this. You will get a negative slope. Log P and then log P. You are getting that a negative slope. There is a negative slope, positive slope and a negative slope you will get. Okay. So these are the graphical representation for the Boyle's law. Relation between the density or relating with rates are consequences of Boyle's law. Consequences of Boyle's law we are going to discuss now. So what is the Boyle's law? Says that P1 V1 equal to P2 V2. P1 V1 equal to P2 V2. Let it be. Okay, you know very well what is density. Density D equal to mass by volume. Mass by volume. Okay. From this relation, if you want to V equal to M by mass by density. Right? So for me, V is the M by D mean what is the V1? M D1. Sir, why you are not putting M1? M1, M is a constant. We are a fixed mass. What is the Boyle's law says that at a constant temperature for the fixed mass of the substance, the mass of the substance should not be varying. So that is fixed mass. So that is constant. We can take M. Likewise, V2 you can write M by D2. So now I am going to substitute the V values into the equation 1. Let's see if you consider the main equation. So what is that? P1. What is V1? Instead of V1, I am putting M by D1. That is equal to P2 M by D2. Let me write like this. Okay. So this is constant. Both sides can be cancelled. M by M cancelled. So this relation may be P1 by D1 equal to P2 by D2. It says that pressure is directly proportional to the density. Simply, you can say pressure is directly proportional to the density, whereas pressure is inversely proportional to the volume. There's a difference. Okay. Till you want to simplify this, T1 T2 equal to B2 T2. Like that also we can expound. These may be used in the problems. They may ask questions. They give a pressure and volume, they are asking the density. Or density will be provided, they may ask pressure. Like this, if they ask the questions, you can go with this is consequences of Boyle's law. This is consequences of Boyle's law. Then, theoretical explanation. How we can theoretically explain that Boyle's law? See, consider this is a container, closed container. Okay. The molecules of gas, you consider 10 molecules. For this is imaginary, you cannot measure the particle size. Just I am saying that there are 10 molecules of the gases in the container. What is the pressure? The force exerted by the gaseous molecule inside the container. The walls of the container they may define. So at a time, all the molecules are hitting the walls of the container. This is called pressure. Okay, hitting the walls of the container. This is called pressure. Now what happened? This is totally 10 molecules are there. Or till in simple way of explaining you, this is not scientific explanation. I am giving you explanation, a simple explanation. Boyle's law. See, in the ground, consider 10 students are there in the ground. I asked around the ground for a time. They are running and they are in the center. They go and come. This is hitting. Yes, is molecule hitting. They are going and coming. This is called. I asked them to run. After some times, the same. Here near 10 members are there. You imagine that there are 10 members are there. They are running and going. This is called the pressure. The 10 particles are there. They are moving and hitting the walls of the container. After some times, I am same 10 members, same power. I am reducing the circle like this. Now, what is happened? This is half of the circle. One of the I reduce the circle. I asked them to move. The same 10 members. Now what happened? The hitting time, the colliding times increases because for a time sake, they are going and coming. It may take number of colliding is very less in the larger circle, whereas the circle is reduced in a small. The same persons they are hitting the wall of the container more time. That's happening here. After volume is reduced, the space occupied is reduced. The force acting on them is more. The force is increasing, whereas area is reduced. What is called pressure? Pressure, force by area. Area reduced, force increased mean automatically what happened? Pressure increases. This is the logic behind the Boyle's law. If you know clearly that, then you can easily understand why the volume is reducing when the pressure is doubled. Boyle's the final statement of Boyle is nothing but whenever volume is reduced to the half, the pressure is doubled. Now I think it's clear. For this circle, they are hitting time. Number of colliding is very less comparatively when it is reduced. Likewise, gaseous molecule, when the volume is nothing but a space occupied by the substance. So the space is reduced, number of collision will be more. Number of collision will be more, the force exerting by this is more, the force increases, area decreases, automatically pressure is increases. This statement. Before that we have experiment done. How much increases will be there? Exactly half of the volume is reduced, pressure is doubled. That's why for 760 mm of mercury is the increases. 760 mm of mercury is nothing but 1 atmosphere. So after pouring 760 mm of 1 atmosphere, so the V1 is 1 liter. P1 equal to 1 atmosphere mean. After reducing, V2 is half liter and the P2 is 2 atmosphere. This is learned. See here, 1 liter is reduced to half of the volume is reduced at the same time. If the volume is reduced to half the time, the pressure increases doubles. This is Boyle's law experiment. Okay, then how we are applying in Boyle's law in our day-to-day life. Let me explain this also. All aeroplane compartments containers are artificially pressurized. The bus, train, we are not artificially pressurized. But whereas aeroplane cabins are artificially pressurized. Why, sir? This is a question. They may ask in a 2 mark or 3 mark way. Why the aeroplane compartments are artificially pressurized mean, you know very well, when altitude increases, pressure will be decreasing. Altitude increases, pressure will decrease. When aeroplane take off, the altitude normally increases. You go on moving, there will be a pressure will be reduced. If pressure will be reduced mean volume will be increased. See, pressure reduced, volume, according to Boyle's, what is the pressure is inversely proportional to its volume. Pressure is decreases, volume automatically increases. So, if we imagine that this is a room, we are being 10 or 20 members are there. We are breathing and breathe out the air. It is sufficient enough in the land itself. When they take up to the sky, the same room contains number of gaseous particles because pressure is reduced. Pressure is reduced mean volume will be automatically, the pressure reduced mean the number of particles in this area will be less. So there will be lack of oxygen inside the cabin. Aeroplane cabins, there will be lack of oxygen. That is not sufficient for our breathing purpose. That's why if it is, it should be balanced. Or otherwise, we may die. There's chances for death. In order to avoid these things, all the cabins of aeroplane or airbuses, they are artificially pressurized. The pressure will be even. Artificially pressurized. Even the altitude is changes, there is no pressure variation. Pressure inside the cabin will be same as in the land itself. So there is not at all problem. Pressure decreases, there will be a particles, number of particles will be within the area will very less. So air very less mean number of particles will be reduced. Number of particles will be reduced mean the oxygen demand takes place. The lack of oxygen may causes death also. That's why the aeroplane cabins are artificially pressurized. Then one more question. When you take out the mountains, you may have the pain in the air. Okay, that's also explained by the Boyle's law. What happened? Here also altitude increases. Your bike or in a bike you may find in a buses car when you climb up in the mountains, there you may see that trouble in your air, the pain you may causes. Why? Because here the air drum there is a pressure. Out of the atmosphere there is a pressure. This is pressure of atmosphere. This is inside the air drum there is a pressure. Pressure of the air. Okay, inside the air. If there is a equilibrium exists between these two. Whenever the equilibrium exists in anything else, there is no problem. Mutual understanding like this. Both are equal. What happens when you climbing up into the mountains, there is a equilibrium is disturbed. Whenever the equilibrium is disturbed, there altitude increases while climbing the mountain, the pressure decreases. Pressure decreases mean inside the air drum in our air, the pressure exert to tend to come out. That's why you are having the feel of pain in your ear. Okay. It can be avoided by yawning. When you are yawning open your mouth. That time the air pressure between the air and the atmosphere, it is neutralized. That's it. Okay. These are the consequences or explanation of the Boyle's law. Let us have one problem. After that we can wind up this class. P1, V1, P2, V2, P3, V3. They will be in the paragraph like I am giving you data. P1 is 1 atmosphere. V1 is 1 decimeter cube or 1 liter. P2 is 2 atmosphere. What is V2? This is a question. Then we don't know P3, but V3 is given. You are provided with the V3, volume 3 is given 0.25. So what is the necessary thing is we need to find a V2. Two problems are there. We need to find a V2 and a P3. These two things we need to find. According to Boyle's law, what is the formula? P1 V1 equal to P2 V2. That is equal to P3 V3. This is we have a formula. Okay. By using take this area for this problem. P1 V1 equal to P2 V2. That is only I am taking. P1 I have 1 atmosphere, V1 I have 1 decimeter cube or 1 liter. Then P2 2 atmosphere, V2 I don't know. That is I need to calculate. So 1 2 V2, then V2 equal to 1 by 2, that is equal to 0.5. So 0.5 decimeter cube V2. Are you clear with it? This question is, what is the second volume? First pressure, first volume, second pressure, second volume is asked. So to find this, I am going to calculate P1 V1 equal to P2 V2. So P1 is given 1 atmosphere, V1 also is there 1 decimeter cube, P2 is also provided 2 atmosphere, V2 is asked. By substituting these values I am getting Boyle's law. This is Boyle's law. By using Boyle's law I am getting the second volume, that is 0.5 decimeter cube. That is not over. The one more question is there in the same problem. P3 is asked. So I am taking this P1 V1 equal to P3 V3 also we can take. Both are same. We can take. Otherwise P2 V2 that is equal to P3 V3. Among these two you can use any one of this formula. Any one of this formula you can use and you can find it. So let me use by this P1 V1 equal to P3 V3. So I know P1 1 into volume also V1 also 1, that is equal to P3 I don't know, so P3 I am keeping like this, V3 I know, that is 0.25 I have given. So what is there? 1 into 1 1, P3 into 0.25. Okay, and P3 equal to 1 by 0.25. If you use this formula, P2 V2 equal to P3 V3, what is P2? 2. What is V2? V2 already we find out, no? What is V2? It equals to 0.5 as we found out. Then P3, we don't know P3. But V3 is given 0.25. Okay. Then P3 equal to 2 into 0.5 by 0.25. That's 2. That is equal to 4. You are getting that? 4 is the answer. If you simplify this, 1 by 12. In both cases, we are getting the same answer. Okay. So this is a Boyle's law formula. We can use for this. We can use two formulas: P1 V1, P2 V3. If you use anything else, you are getting this final same answer. Okay. So what is the solution? After this working out, you need to write the solution that V2 is 0.5. V2 is a volume, so the unit will be decimeter cube. Then P3 is a pressure, P3 equal to the pressure atmosphere level, that is 4 atmosphere. This is called result. Final result should be given. Whenever physical chemistry always dealing with the problem, you may find the 50% of theory question, more than 50% of problematic question. The question will not be like this, every data is given. There will be theoretical form. The question will be in a theoretical form. You have to take a hints first, solution. What is given, what is asked. That is a first problem. When you classify them, you have a formula, you know very well, all of you know very well, P1 equal to P2 V2, this is very simple to recall. But how we are using this, first we have to write the solution first. What is given? Pressure 1, pressure 2 is given, pressure 2 is asked, volume 1, volume 2 is given. Like this, you have to separate the problem and write the formula and substitute it, you can get it, the answer. The scientific problem, mostly in a physical chemistry problem, it is very easy. It is a big thing. Is a calculation part will be easy. Finding the solution, how, what is given, what is asked, that you need to decide. That's all about this Boyle's law. Okay, students. Now it is very clear enough. I think so. Again, I am repeating that what is called the Boyle's law. Boyle's law is defined as at a constant temperature with a fixed mass, pressure is inversely proportional to its volume. P inversely proportional to its volume. That is a Boyle's law. I hope that you may understand everything is clear. Tomorrow we will discuss about the Charles law. Thank you.